Hello, discrete math fans. Let's take this argument. Let's see if it's valid. If an infinite series converges, then its terms go to 0. The series, sum n goes from 1 to infinity if n squared over n factorial converges. Therefore, the limit as n goes to infinity if n squared over n factorial is equal to 0. Now, this form is actually universal modus ponens. What we don't see here is an implicit quantification. That in front of this, maybe we should have a for all series. For all series, if it converges, then the terms go to 0. So this is a valid argument because its form is universal modus ponens. Now here's a similar argument that uses universal modus tollens. Now we didn't describe what universal modus tollens is, but once you know what universal modus ponens is, and if you know what modus tollens is, then you can write down what universal modus tollens is. If an infinite series converges, then its terms go to 0. The limit as n goes to infinity of 3n over 4n plus 1 is not equal to 0. Therefore, the series n goes from 1 to infinity of 3n over 4n plus 1 diverges. And this particular argument is using what you would call in second semester calculus, you would call that the test for divergence. This is a way of testing to see that an infinite series diverges. Keep in mind that the test for divergence, there's a big mistake that sometimes gets made, that sometimes people will say, well, the terms go to 0, that tells me that the series converges. No, you can't do that. That's a converse error that you would be making. Okay, that's all for now.